Have you ever stared up at the night sky and wondered about the secrets hidden among the stars? The universe is vast, mysterious, and full of wonders we're only beginning to understand. Tonight, we're going to drift through 100 fascinating facts about the cosmos, from exploding stars to distant galaxies, and even the stardust that makes up you. Let's take a gentle journey across space and time, letting the story of the universe lull you into wonder and calm. By the end, you might just feel a little closer to the cosmos itself. Fact 1. The universe began with the Big Bang. Imagine absolute silence. No stars, no planets, no light. Just a stillness so deep it's almost impossible to imagine. Then, in a single, breathtaking instant, everything changed. About 14 billion years ago, something happened that would become everything we know today, the beginning of the universe. It wasn't an explosion in space, because there was no space yet. The Big Bang was the sudden expansion of space itself. In that tiny fraction of a second, energy burst outward, carrying the seeds of everything that would one day exist. Galaxies, stars, worlds, even you. The early universe was unimaginably hot and dense, glowing brighter than anything we can picture. But as it expanded, it cooled, and tiny particles began to form. Those particles came together to make atoms, and from atoms stars were born. The Big Bang wasn't a single moment that ended. It's still happening in a way. The universe is still stretching, still growing. Every point in space moves away from every other point, like dots on a balloon that's slowly being inflated. It's humbling to think that all of us, everything we see, touch, and feel, came from that same origin. So when you look up at the night sky, you're not just seeing stars, you're seeing the faint echo of that first great expansion, the universe's first heartbeat still rippling through time. Fact 2. Time and space expanded together. Before the Big Bang, there was no before. Time itself hadn't started yet. It's one of the strangest ideas in all of science, that time and space were born together, intertwined like threads of the same fabric. When the Big Bang occurred, it didn't just send matter outward, it created the very stage where everything could exist. Think of it this way, you can't have an explosion in space if there's no space to explode into. The Big Bang didn't happen somewhere, it happened everywhere. Space unfolded, and time began to tick. Every second that's passed since that first moment is part of this cosmic timeline that started then and continues now. As the universe expanded, so did the flow of time. The farther away something is, the farther back in time we see it. When you look at a distant galaxy through a telescope, you're actually looking millions or even billions of years into the past, seeing it as it was when the light first began its journey. It's a gentle reminder that time isn't constant. It stretches, bends, and flows differently, depending on where you are and what surrounds you. Time and space dance together, creating the rhythm of existence. Every sunrise, every heartbeat, every moment you experience, all a part of that same unfolding story that began when the universe itself learned how to keep time. Fact 3. Cosmic background radiation, the universe's afterglow. If the universe had a baby picture, this would be it, a soft, faint glow that fills the cosmos. It's called the cosmic microwave background, or CMB, and it's the leftover light from the Big Bang itself. Long ago, when the universe was young and full of energy, light couldn't travel freely. It bounced endlessly between particles, trapped in a dense fog. Then, about 380,000 years after the Big Bang, the universe cooled enough for atoms to form. Suddenly, light could move freely, and that light has been travelling ever since. Over billions of years, it stretched into longer wavelengths as space expanded, turning into the gentle microwave radiation we can detect today. When scientists first discovered it in the 1960s, they thought their antennas were malfunctioning. But the faint static they heard was the universe whispering its earliest memory. The CMB is a kind of time capsule, holding clues about the universe's first moments, its density, its age, even its shape. It's astonishing to think that everywhere you go, that ancient light is still around you, invisible to your eyes but always present. the soft afterglow of creation itself. The next time you stare into the night sky, remember you're bathed in the oldest light there is. Fact 4. The universe is still expanding. You might imagine the Big Bang as something that happened long ago and then stopped. But here's the secret. It never stopped. The universe is still expanding even right now in every direction. Galaxies aren't just floating in space. Space itself is stretching between them. It's a strange thing to picture. Imagine drawing dots on a balloon. As you inflate it, each dot moves away from the others. None of them are moving on their own. The balloon's surface is expanding beneath them. That's what's happening in our universe. Every moment more space is being created, and galaxies drift apart carried by this cosmic expansion. Scientists once thought that gravity might slow this stretching, maybe even reverse it someday. But then they found something unexpected. The expansion is speeding up. Some invisible force called dark energy is pushing everything apart faster and faster. So the night sky isn't static, it's alive, in motion. The distances we measure today won't be the same in the far future. One day, galaxies so distant we can see them now will slip beyond the reach of our telescopes, disappearing into the cosmic horizon. The universe keeps unfolding, endlessly, quietly, beautifully. Fact 5. Galaxies drift farther apart. Each second out there in the great ocean of space, galaxies are like ships carried by invisible tides. Every second that passes, those tides push them farther apart. The universe's expansion isn't gentle. It's relentless, stretching everything from the largest clusters of galaxies down to the very fabric of space-time itself. If you could freeze time and draw a line between two distant galaxies, that line would grow longer each moment. Not because the galaxies are moving through space, but because space itself is growing between them. It's like an endless current that carries everything forward. The farther away a galaxy is, the faster it moves away. This was first discovered by astronomer Edwin Hubble, who realized the universe wasn't still. It was breathing, expanding, alive. His discovery changed how we see everything. It means that looking across the universe is like looking through time. The light from those distant galaxies began its journey long before Earth even existed. Some of the light reaching us tonight has travelled for billions of years, crossing the growing gulf of space. And as we gaze at those faint, shimmering galaxies, we're seeing a story that's still unfolding, one of endless distance, quiet motion, and the slow, graceful drift of everything that ever was. Fact 6. Space. Itself can stretch without limits. It's hard to imagine something that doesn't have an edge, but that's what space is. It doesn't end somewhere. It just keeps going, stretching endlessly in all directions. When we say, the universe is expanding, we don't mean galaxies are flying through space like debris from an explosion. Instead, space itself is stretching, carrying galaxies along with it. Picture a loaf of raisin bread rising in the oven. As it expands, the raisins move farther apart, but not because they're moving on their own. The dough between them is stretching. That dough is space. No matter how far you go, there's always more space ahead. There's no wall, no barrier, no edge where everything stops. Even stranger, this stretching doesn't require permission from the speed of the light. Galaxies far enough away can move apart from us faster than light itself. Not because they're breaking the laws of physics, but because the space between us and them is expanding. It's a beautiful, mind-bending idea. The universe has no outside, no center, and no end. Just an infinite growing fabric where time and distance are constantly unfolding. Somewhere in that vast stretch we exist, a small, thinking piece of something boundless. Fact 7. Light takes time to travel. We see the past. Every time you look at the stars, you're looking back in time. That gentle shimmer in the night sky isn't what those stars look like now. It's what they looked like when their light first left them, sometimes thousands, sometimes millions of years ago. Light travels incredibly fast, about 300,000 kilometers per second, but even that speed has limits in a universe this vast. When we say the sun is 8 light minutes away, it means the sunlight warming your skin left the sun 8 minutes ago. If the sun vanished this instant, we wouldn't even know until those last rays reached us. Some of the light we see from distant galaxies has been travelling for billions of years. When it finally reaches our eyes or telescopes, it carries a story from the dawn of time, from stars that may no longer exist. So when you look into the night sky, you're seeing a cosmic photograph, filled with ancient light, each dot a memory of something long gone yet still glowing. It makes every starlit night feel sacred in its own quiet way. Not because of what's out there right now, but because of what's been travelling toward us for eons, just so we could see it. Fact 8. The observable universe is only a small part. What we can see is not all there is. The observable universe sounds enormous, about 93 billion light-years across, but it's just the part of the cosmos whose light has had time to reach us. Beyond that, there could be endless more, space we can't see, maybe we'll never see, because its light hasn't had enough time to arrive. Imagine standing in a vast, dark field with a small lantern. The circle of light around you is all you can see, but the field goes on forever beyond the glow. That's what our view of the universe is like. We're standing in the middle of a cosmic night, surrounded by a small sphere of light called the observable universe, and as time passes, that sphere grows. Every second, more light reaches us from places farther away, but because space keeps expanding, some regions are racing away faster than light, meaning their glow will never reach us. So when astronomers talk about the universe, they know we're only describing a fraction of it. There may be entire galaxies, even vast structures forever hidden beyond our cosmic horizon. The truth is both humbling and comforting. What we see is grand enough, but the unseen might be even more magnificent. Fact 9. Dark matter holds the galaxies together. Galaxies are spinning far too fast to stay intact. At least they would be if all that held them together were the stars and gas we can see. By the laws of physics, they should have flung themselves apart long ago, but they haven't. Something invisible is holding them in place. Something we call dark matter. We can't see it, touch it, or detect it directly, but we can see its effects everywhere. It bends light from distant galaxies, shapes how clusters form, and provides the extra gravity needed to keep galaxies whole. Scientists estimate that dark matter makes up about 27% of the universe. Everything we can actually see, stars, planets, people, adds up to less than 5%. The rest is this mysterious silent substance that doesn't emit or absorb light. It's like an invisible web, connecting and anchoring galaxies in space. Without it, the universe would look completely different, thin, scattered, and unstable. We don't know what dark matter truly is yet. It might be made of undiscovered particles, or something beyond our understanding of physics. But its quiet grip shapes everything we know, the unseen scaffolding that keeps the universe from falling apart. Fact 10. Dark energy pushes the cosmos apart. If dark matter pulls everything together, dark energy does the opposite. It pushes, and it's winning. About 2/3 of the universe is made up of this mysterious force that's driving galaxies away from one another faster and faster. For a long time, scientists assumed gravity would slow the universe's expansion. But in the late 20th century, when astronomers measured distant exploding stars, they made a shocking discovery. The expansion was speeding up. Something unknown was fueling this acceleration. They called it dark energy. We don't know what it really is. It might be a property of space itself, the natural tendency of the universe to stretch. Or maybe it's something even stranger, something beyond our current science. But its effect is clear. It's reshaping the cosmos on the grandest scale imaginable. Over billions of years, dark energy could stretch space so much that galaxies beyond our local group will drift out of view, their light fading forever. The night sky will grow emptier, quieter, but the story of expansion will continue, written in the silence of space. It's one of the universe's greatest paradoxes. Invisible forces we don't yet understand deciding the fate of everything we can see. Fact 11. The Milky Way has over 100 billion stars. When you look up at the night sky, what you're really seeing is just a tiny part of something enormous. Our home galaxy, the Milky Way. It's a vast island of stars stretching 100,000 light-years across, with over 100 billion stars shimmering within it. And each one of those stars might have planets, moons, and stories of their own. From Earth, we only see the Milky Way as a soft, cloudy band across the night sky. But if you could step outside our galaxy and look back, you'd see a majestic spiral, glowing arms curling around a bright centre, dust and gas weaving between the stars like rivers of light. Most of those stars will never be visible to us. Some are young and blue, burning fiercely. Others are ancient, dim embers fading into red. There are stars in pairs, clusters, and dense swarms, all bound together by gravity in a silent dance that's been going on for billions of years. And in one small corner, our sun circles quietly, a single point among billions. The Milky Way reminds us how small we are, but also how connected we are to everything else. Every atom in your body was once inside a star somewhere in this galactic ocean. You don't just live in the Milky Way, you're made of it. Fact 12. Our galaxy is a barred spiral. If you could step far enough away from the Milky Way to see its full shape, you'd find it's not just any spiral galaxy, it's a barred spiral. That means it has a bright, elongated bar of stars running through its centre, with spiral arms unfurling gracefully from each end like ribbons. This bar isn't solid, of course. It's made of billions of stars moving together, guided by gravity, forming one of the most mesmerizing structures in the cosmos. The spiral arms aren't fixed either. They're like waves of motion, areas where stars and gas cluster together before drifting onward. Our solar system sits out in one of those arms, the Orion arm, about halfway between the centre and the edge. From our tiny spot, we can't see the galaxy's full shape, but through telescopes and careful measurements, astronomers have pieced together this grand design. The bar at the Milky Way's core helps channel gas inward, feeding new stars and fueling the massive black hole that sits in the very heart of the galaxy. So even though we can't see it, the Milky Way's bar plays a vital role in keeping this cosmic ecosystem alive and active. The next time you see that faint band of light across the sky, remember, you're looking along the edge of one of the most beautiful spirals in the universe. Fact 13. The Milky Way rotates. Once every 230 million years. Everything in the Milky Way is moving. The stars, the gas, the dust, even our own sun. Together they're all part of the galaxy's slow, majestic spin. It takes about 230 million years for the sun to complete a single orbit around the centre of the Milky Way. That's an almost impossible stretch of time to imagine. The last time we were in this part of our galactic orbit, dinosaurs ruled the Earth. Since then, continents have moved, mountains have risen and eroded, and species have come and gone. Yet the sun just keeps circling, steady as ever. As our solar system makes its journey, it weaves up and down through the galaxy's disk, passing through regions of dust and light, near clouds of gas and newborn stars. Each orbit is a long, slow voyage through a living cosmic landscape. The Milky Way's rotation is what holds everything together. Stars bound by gravity, moving in harmony through the vastness of space. It's not a rigid spin like a wheel, but a flowing, graceful motion where stars closer to the centre move faster than those at the edges. So when you step outside on a clear night, know that you're not standing still. You're riding through the galaxy at nearly 200 kilometers per second, part of an endless celestial journey that's been going on for billions of years. Fact 14. The Andromeda Galaxy is our neighbour and future merger. Far across the dark sky, beyond the reach of the naked eye in most places, lies the Andromeda Galaxy, our closest galactic neighbour. It's about 2.5 million light-years away, yet so large and bright that, under clear skies, you can see it as a faint smudge of light. Andromeda is a spiral galaxy, much like our own, but slightly bigger, home to perhaps 1 trillion stars. For now, it drifts quietly in the distance, but it's moving toward us. Slowly, steadily, the pull of gravity is drawing our two galaxies together. In about 4 billion years, they'll collide and merge into a single enormous galaxy, sometimes called Milkomeda. It sounds dramatic, but it won't be a crash like cars on a highway. Space is mostly empty, so most stars will pass right by one another. The real change will be in structure. The galaxies will stretch, twist, and reshape into something entirely new. For anyone watching from a safe distance, it would be a breathtaking sight. Stars swirling, gas clouds igniting into new suns and the birth of a new galactic form. In the end, the Milky Way and Andromeda will no longer be separate. They'll become one, a cosmic union written across the stars. Fact 15. There are trillions of galaxies in the universe. Every dot of light you see in the night sky belongs to our Milky Way. But if you point a telescope deep into what seems like an empty patch of sky, you'll discover something astonishing. It's filled with galaxies. Each one is a collection of billions of stars, worlds, and wonders. Astronomers now believe there are trillions of galaxies in the observable universe. Some are massive spirals like ours, others are small and faint, barely visible. There are galaxies that glow red with newborn stars, and others so old their light has faded to a whisper. The sheer scale of it all is humbling. Each galaxy might hold its own civilizations, its own suns and moons, its own versions of beauty and mystery. And beyond the galaxies we can see, there may be countless more, forever hidden beyond the reach of light. When you think about it, the universe isn't just vast, it's overflowing with stories. Every galaxy is like a single page in an endless book. We've read only a few lines so far, but even those have shown us how extraordinary existence can be. Somewhere out there, beyond our little spiral arm, trillions of galaxies drift silently, each one glowing softly in the dark, adding its own note to the grand cosmic symphony. Fact 16. Elliptical galaxies are the giants of the cosmos. In the vast silence of the universe, some galaxies rise like cosmic giants, immense, smooth, and ancient. These are the elliptical galaxies, the quiet elders of the cosmos. Unlike the graceful spiral arms of galaxies like our Milky Way, ellipticals are more like glowing spheres or elongated clouds, filled with old stars that have burned for billions of years. Their light is soft and golden, a sign of age and calm stability. Elliptical galaxies can grow to extraordinary sizes, some stretching across millions of light years, containing trillions of stars. They often sit at the hearts of galaxy clusters, their gravity drawing in smaller companions, slowly consuming them. Over countless ages, the collisions that once gave them life have faded, leaving only their massive forms adrift in space. There's a quiet beauty in their simplicity. No swirling arms, no bursts of colour, just the steady glow of countless ancient suns. Looking at an elliptical galaxy is like peering into the deep history of the universe itself, where everything has slowed, settled, and found peace in the endless dark. Fact 17. Dwarf galaxies. Drift quietly in the shadows. Not all galaxies are grand and radiant. Some, like faint whispers of light, move quietly through the cosmic dark. These are the dwarf galaxies, small, fragile, and easily overlooked. While the giants boast billions of stars, a dwarf galaxy may hold only a few million, scattered like grains of sand. They orbit larger galaxies, including our Milky Way, almost like companions on a slow cosmic dance. Some are irregular and faint, their shapes warped by the pull of nearby giants. Others, like the small and large Magellanic clouds visible from Earth's southern skies, shimmer like ghostly smudges, small yet full of wonder. Despite their size, dwarf galaxies are vital to the story of the universe. They are thought to be the building blocks of larger galaxies, merging and blending over time to form the vast structures we see today. In their quiet drifting, they carry the memory of creation, the first sparks of starlight from the early universe. Fact 18. Galaxy clusters form cosmic webs. If you could step back far enough to see the universe as a whole, you'd find that galaxies aren't scattered randomly. They gather into clusters, vast families of hundreds or thousands of galaxies bound together by gravity. And beyond these clusters, something even greater appears. A cosmic web, stretching across the universe. This web is made of filaments, threads of galaxies and dark matter, separated by enormous voids where little exists. The pattern looks almost alive, like a vast, luminous network suspended in black space. It's one of the most breathtaking structures ever discovered, showing that the universe has form and rhythm on the grandest scales imaginable. Each cluster within the web shines with the light of trillions of suns. Between them lie the dark voids, immense spaces of almost nothing, reminding us how delicate and rare matter truly is. The cosmic web tells us that even the emptiest regions of the universe are part of something vast and connected, a silent architecture of creation stretching endlessly outward. Fact 19. Colliding galaxies create new stars. When galaxies meet, it's not a crash in the way we imagine. It's more like two great clouds drifting through one another, their stars rarely touching but their gravity stirring everything into motion. During these slow encounters, lasting millions of years, new stars are born. The gas and dust inside each galaxy collide and compress, igniting brilliant waves of star formation. Entire regions light up, forming dazzling blue clusters that shine like fireworks in space. What might seem destructive is actually a process of renewal, old material reshaped into something bright and new. Our own Milky Way will one day meet the Andromeda Galaxy in this kind of cosmic embrace. Over time, the two will merge into a single, enormous elliptical galaxy. There will be no chaos, no explosion, just a gradual blending, a slow dance of stars creating new light where there was once separation. Fact 20. Supermassive black holes anchor galaxies. At the centre of nearly every galaxy lies something invisible yet immensely powerful, a supermassive black hole. These dark centres can be millions or even billions of times heavier than the Sun. Though they cannot be seen directly, their gravity shapes everything around them, anchoring the galaxy like a hidden core. Gas and dust swirl toward them, heating up and glowing with incredible energy before crossing the point of no return. Some black holes are calm, quietly resting in the dark. Others blaze with light as matter falls into them, forming brilliant quasars visible across billions of light years. Our own Milky Way holds such a black hole at its heart, Sagittarius A. It sits quietly now, a giant asleep, but its presence binds the galaxy together. In a way, black holes remind us that even the darkest places in the universe can hold the deepest influence, unseen, yet essential to everything that orbits around them. Fact 21. Every star is a nuclear furnace. Every point of light in the night sky is more than just a distant sparkle. It's a nuclear furnace, burning with unimaginable power. Inside each star, atoms collide and merge in a process called fusion, releasing energy that travels across space as heat and light. In the heart of a star, hydrogen becomes helium, and with every fusion a tiny bit of mass turns into pure energy. The same process that powers the sun. This isn't fire as we know it. There's no oxygen, no flame, just pressure and heat so intense that matter itself transforms. Stars shine for millions or billions of years, stable only because gravity and fusion are perfectly balanced. Gravity pulls inward, trying to collapse the star, while fusion pushes outward, holding it open in harmony. That balance is the quiet heartbeat of the universe. Without it, there would be no light, no warmth, and no life. Every star you see in the sky is a self-sustaining engine, burning silently in the dark, a reminder that creation itself is a process of balance between pressure and peace. Fact 22. The Sun is a middle-aged star. Our Sun, the centre of our solar system, the giver of warmth and daylight, is not young, nor is it old. It's a middle-aged star about halfway through its life. Born roughly 4.5 billion years ago, it has been burning steadily ever since, fusing hydrogen into helium in its bright, stable core. This steady phase, called the main sequence, is the calm period of a star's existence, long, balanced, and remarkably peaceful. Eventually the Sun will exhaust the hydrogen in its core and begin to change. It will swell into a red giant, shed its outer layers, and leave behind a glowing remnant called a white dwarf, a quiet ember of what once was. But that time is far away, billions of years in the future. For now, the Sun remains constant, a golden presence in our sky, rising and setting with the rhythm of life itself. Each dawn is a reminder that the same light that warmed the first humans still touches us today. Fact 23. Stars are born in clouds of dust and gas. The birthplaces of stars are hidden within vast dark clouds of gas and cosmic dust. These regions, called nebulae, drift quietly through galaxies like misty shadows. Deep within them, gravity begins its patient work, drawing particles closer and closer until a clump forms dense enough to ignite. As the gas compresses, the temperature rises. Slowly, a new star begins to glow, first faintly, then brighter, until it pushes away the dust around it and steps into the light. What began as cold darkness becomes a shining newborn, a star entering its long, luminous life. Some of these stellar nurseries are visible from Earth, like the Orion Nebula, a vast cloud where thousands of young stars sparkle in their first light. It's a place of quiet creation, where time moves slowly and gravity sculpts new suns from the simplest elements. Every star you see began this way, not in fire but in stillness and dust. Fact 24. A star's colour reveals its temperature. When you look at the stars, you'll notice that not all of them shine the same. Some glow cool and red, others bright white or electric blue. That colour isn't just beauty, it's information. It tells us the temperature of the star's surface. Cooler stars, around 3000 degrees Celsius, glow with a soft orange or red hue. Hotter stars, sometimes over 30,000 degrees, blaze blue or white. Our Sun, shining with a gentle yellow light, sits comfortably in the middle, at about 5,500 degrees. Astronomers can tell a star's age, size, and even its chemical makeup just by studying that colour. It's like a fingerprint written in light. When you gaze up at the night sky, every colour tells a story. A quiet whisper from across the cosmos, revealing the conditions of distant worlds we may never see. Fact 25. The biggest stars burn the fastest in the universe. Being massive comes at a cost. The larger stars, though dazzling and powerful, live fast and die young. Their immense gravity forces their cores to burn fuel at a furious rate, producing light and heat far beyond that of smaller stars. But this brilliance doesn't last. A star like our Sun may shine for 10 billion years, but a giant star, dozens of times more massive, might last only a few million. They live in extremes, hotter, brighter, and far more unstable. When they finally run out of fuel, they end their lives in spectacular explosions called supernovae, scattering heavy elements into space. From that cosmic debris, new stars and planets are born, including the elements that make up Earth and us. So even though the biggest stars burn out quickly, their brief lives enrich the universe, leaving behind the raw materials for everything that follows. In their ending, they begin again, their light echoing across time long after they're gone. Fact 26. When a star dies, it can become a supernova. Every star has a life cycle, and for some, the end is nothing short of spectacular. When a massive star runs out of fuel, it loses the balance that kept it stable for millions of years. Gravity takes over, and the core collapses in a fraction of a second. The result is a supernova, one of the most powerful explosions in the universe. In that instant, the star releases more energy than our Sun will in its entire lifetime. The light can outshine an entire galaxy, visible even from millions of light years away. What's left behind depends on the size of the original star, sometimes a dense core called a neutron star, and sometimes something even more mysterious. But the story doesn't end with destruction. Supernovas scatter the elements created inside stars, carbon, oxygen, iron, into space. These are the ingredients of planets, oceans, and living things. In the end, a star's death becomes the beginning of something else. Fact 27. Supernovas forge the elements of life. Everything around you, your bones, your blood, the air you breathe, was once inside a star. Ordinary stars create lighter elements like helium and carbon, but the heavier ones, gold, silver, iron, are forged in the intense heat of supernovas. When a star explodes, it becomes a cosmic forge. Temperatures soar into the billions of degrees, and atoms fuse to create elements that didn't exist before. Those new elements are then scattered across the galaxy, blending into gas clouds that later form new stars, planets, and life itself. So in a very real sense, you are made of stardust. Every breath you take, every cell in your body, carries the signature of ancient stars that lived, died, and exploded long before the Earth was formed. It's a humbling thought that everything living today was once part of something shining in the deep, quiet dark. Fact 28. Some stars collapse into neutron stars. When a star much larger than our Sun dies, it doesn't simply fade away. If the remaining core after a supernova is heavy enough, gravity crushes it down into something incredibly dense, a neutron star. Imagine the mass of the Sun squeezed into a sphere barely 20 kilometers wide. A teaspoon of this material would weigh more than 1 billion tons. Neutron stars are strange and silent. Their gravity is so strong that they bend space and time around them. Their magnetic fields are trillions of times stronger than Earth's, and some spin hundreds of times each second. Even though they're small, they're among the most powerful objects in the universe, quiet remnants of once blazing stars, continuing to twist and spin in the endless dark, reminders that even in collapse, the universe finds a way to keep turning. Fact 29. Pulsars spin like cosmic lighthouses. Among neutron stars, there's a special kind called a pulsar. These stars spin so rapidly that beams of radiation shoot out from their poles, sweeping across the cosmos like the light from a distant lighthouse. Each pulse we detect on Earth is a reminder of that rotation, a steady heartbeat from across space. Some pulsars spin hundreds of times per second, more precise than the best atomic clocks. Astronomers use them to study gravity, time, and even to navigate through space. They're living proof that even after the violent death of a star, order and rhythm can emerge. When you imagine a pulsar, think of it not as a dead star, but as one that continues to send messages into the dark, spinning endlessly, marking time long after its light should have gone out. Fact 30. Black holes are the final stage of massive stars. If a star is truly massive, even a neutron star can't contain its collapse. Gravity crushes it further, past the point where light itself can escape. What remains is a black hole, a region of space where everything, even time, bends inward. We can't see black holes directly, but we know they're there. We can watch how nearby stars orbit them, or how their immense pull warps the space around them. Some black holes grow by feeding on gas, dust, or even other stars, creating brilliant disks of light as matter falls in. Though they seem like endings, black holes are part of the ongoing balance of the cosmos. They shape galaxies, influence the movement of stars, and may even help recycle matter and energy in ways we don't yet fully understand. Silent, invisible, and endlessly fascinating. They're the universe's reminder that even in darkness, mystery and creation continue side by side. Fact 31. The Sun holds 9.8% of the solar system's mass. Almost everything in our solar system, every planet, moon, asteroid, and comet, orbits one central powerhouse, the Sun. What most people don't realize is just how dominant it truly is. The Sun holds 99.8% of all the mass in the solar system. Every world we know, including the gas giants, share the remaining fraction. That means nearly all the gravity, all the energy, and all the weight of our cosmic neighborhood belongs to this one glowing sphere of plasma. The Sun's pull keeps every planet in orbit, balancing the entire system like a conductor, guiding an invisible symphony. If the Sun vanished, everything would drift away into cold, endless space. But as it stands, it remains steady and dependable, burning quietly, holding everything together, and reminding us that even in the vast emptiness of the cosmos, one center of light can shape the destinies of many. Fact 32. Mercury has no atmosphere to hold heat. Mercury, the smallest planet and the one closest to the Sun, is a world of extremes. In the daytime, its surface bakes under intense sunlight, reaching temperatures hot enough to melt metal, but once night falls, it plunges into deep cold, hundreds of degrees below freezing. Why such extremes? Because Mercury has almost no atmosphere. There's nothing to trap heat, nothing to carry warmth from one side to the other. The planet is bare and silent, covered in craters and dust, like a time capsule from the early solar system. Standing there, if you could, you'd see the Sun enormous in the sky, 3 times larger than it appears from Earth. Yet, the moment it sets, You'd feel the chill of space creep in, fast and unforgiving. Mercury reminds us that sunlight alone isn't enough for comfort. Without the blanket of an atmosphere, warmth simply slips away. Fact 33. Venus is the hottest planet. You might think Mercury is the hottest planet because it's closest to the Sun, but that title actually belongs to Venus. Wrapped in a thick atmosphere of carbon dioxide, Venus traps heat so efficiently that its surface stays around 900 degrees Fahrenheit, hotter than an oven and even hotter than Mercury. The clouds above are made of acid, and the pressure on the surface is like being nearly a kilometre deep under the sea. Yet from orbit, Venus looks stunning, a pale, golden world shrouded in mystery and light. Venus is often called Earth's twin because they're similar in size, but its atmosphere makes it a very different place. It's a cautionary reminder of how fragile balance can be, how a planet's air can decide whether it becomes a home or a furnace. Fact 34. Earth is just the right distance for life. In the grand design of the solar system, Earth sits in the perfect spot. Not too close to the Sun, not too far. This region, known as the habitable zone, allows water to exist as liquid, ice, and vapour. Without this delicate balance, oceans wouldn't flow, clouds wouldn't form, and life as we know it wouldn't thrive. But it's more than just distance. Earth's atmosphere protects it from radiation, holds in warmth, and keeps temperatures steady enough for ecosystems to flourish. Its magnetic field deflects solar winds that could strip the air away. Every sunrise, every gentle rain, every living thing owes its existence to this cosmic balance, a narrow band of conditions that make our world a rare oasis in a cold and empty void. Fact 35. The moon stabilizes Earth's tilt. The moon does more than light up the night sky. It helps keep Earth steady. Our planet tilts slightly as it spins, and that tilt is what gives us seasons. But without the moon's gravitational pull, that tilt could wobble wildly over time, throwing climates into chaos. The moon acts like a stabilizing hand, keeping Earth's axis from shifting too much. It also stirs the oceans through tides, shaping coastlines and influencing the rhythm of life itself. When you look up at the moon, you're seeing more than a glowing sphere. You're seeing the quiet partner that keeps our world balanced. Together, Earth and moon dance through space, their movements intertwined in a slow, graceful balance that has lasted for billions of years. Fact 36. Mars. Once had rivers and lakes. Long ago, Mars wasn't the dry, red desert we see today. Evidence from rovers and orbiters shows that it once had rivers, lakes, and maybe even shallow seas flowing across its surface. You can still see the marks, dry riverbeds, delta patterns, and minerals that could only have formed in water. Billions of years ago, Mars likely had a thicker atmosphere that trapped heat, keeping the planet warm enough for liquid water to flow. Scientists believe rain once fell there, carving valleys and feeding lakes that might have supported simple forms of life. Today, Mars is cold and barren. Its air is thin, and water exists only as ice beneath the soil or as vapour in the air. But every rock, every ripple pattern in the Martian dust is a quiet memory of what once was, a reminder that even the most lifeless worlds may have had moments of warmth and wonder. Fact 37. Jupiter's gravity protects Earth from asteroids. Jupiter is more than the largest planet in the solar system. It's a guardian. With its immense gravity, more than twice that of all other planets combined, Jupiter acts like a cosmic shield for Earth. Many asteroids and comets that wander through space are pulled toward Jupiter before they ever get close to us. Its gravity either captures them, flings them away, or breaks them apart. Without Jupiter, Earth might have faced countless catastrophic impacts over time. You could say Jupiter quietly watches over the inner planets, shaping their safety without anyone noticing. It's a reminder that sometimes the biggest influences in life, or the universe, are the ones we rarely see, working steadily from a distance. Fact 38. Saturn's rings are made of ice and rock. From far away, Saturn's rings look like smooth, shining bands circling the planet. But up close, they're made of countless tiny pieces of ice, dust, and rock, each orbiting on its own path. Some fragments are as small as grains of sand, others are the size of mountains. The rings are thin, only a few dozen meters thick in places, yet they stretch across hundreds of thousands of kilometres. No one knows exactly how they formed. They might be the remains of a shattered moon, or leftover material from the planet's birth. Seen through a telescope, Saturn's rings appear calm and perfect. But in truth, they're full of movement. Billions of icy particles dancing around the planet in endless circles, glinting in the light of a distant sun. Fact 39. Uranus spins on its side. Among the planets, Uranus stands out for one strange reason. It's tilted almost completely sideways. While most planets spin upright like tops, Uranus rolls along like a ball, its poles pointing nearly toward the sun. Scientists think this odd tilt was caused long ago, when a massive object collided with the planet, knocking it over. Because of this, its seasons are extreme. Each pole spends about 40 years in sunlight, then 40 in darkness. Its pale blue colour comes from methane in its atmosphere, which absorbs red light and reflects blue. Seen from space, Uranus looks serene. A cool, distant world quietly turning on its side. A reminder that even in the universe's grand order, there's room for beautiful imperfection. Fact 40. Neptune's winds are the fastest in the solar system. Far beyond the warmth of the sun, Neptune spins in cold darkness. Yet, despite its distance, it's anything but calm. Neptune's winds are the fastest in the solar system, reaching speeds of over 2,000 kilometers per hour, faster than sound on Earth. These powerful winds swirl through clouds of methane, shaping dark storms the size of continents. One of them, the Great Dark Spot, was once seen by the Voyager 2 spacecraft, a massive storm spinning in the blue depths of Neptune's atmosphere. No one fully understands how Neptune's winds move so fast in such a cold place, but perhaps that's what makes it so fascinating. A distant frozen world with storms that never rest, whispering that motion and energy can exist even in the quietest corners of space. Fact 41. Some moons are bigger than planets. When you think of moons, you might imagine small, quiet worlds orbiting giant planets. But in reality, some moons are larger than entire planets. Jupiter's moon, Ganymede, is the biggest of all, even larger than Mercury. Saturn's Titan isn't far behind, wrapped in a thick atmosphere and covered in hazy orange clouds. These moons are worlds in their own right, each with unique landscapes, climates, and mysteries. Ganymede has a magnetic field, something no other moon can claim. Titan has rivers and lakes made not of water, but of liquid methane. It's humbling to realise that not every world needs to circle the sun to be remarkable. Some of the most fascinating places in our solar system quietly orbit others. Reminders that beauty and complexity can thrive in the shadows of giants. Fact 42. Europa may hide an ocean beneath its ice. At first glance, Europa, one of Jupiter's moons, looks like a frozen marble, smooth, pale, and covered in cracks. But beneath that icy shell, scientists believe there's a vast ocean of liquid water. Heated from below by Jupiter's gravity, the ice may hide a global sea deeper than all of Earth's oceans combined. If that's true, Europa could be one of the most promising places to search for life beyond Earth. The water might be warmed by hydrothermal vents, just like those on the ocean floors here at home, vents that, on Earth, teem with life despite total darkness. The idea that an ocean could exist in the cold reaches of space is astonishing. Europa reminds us that life may not need sunlight or surface warmth, only water, energy, and time. Fact 43. Titan has lakes of methane. Saturn's largest moon, Titan, is a world both familiar and alien. Its thick orange haze hides a landscape eerily similar to Earth's. Rivers, lakes, and even rain. But there's one difference. It's not water that flows there. It's liquid methane and ethane. The surface temperature is far below freezing, so methane behaves the way water does on Earth, evaporating into clouds, falling as rain, and collecting into lakes. Titan is the only place in the solar system, other than Earth, known to have stable liquids on its surface. Walking there would be strange. Dim golden light, a thick atmosphere, and lakes that ripple slowly in the freezing cold. It's a glimpse of how familiar patterns can appear in entirely unfamiliar worlds. Fact 44. Enceladus shoots. Water. Plumes into space. Tiny. Enceladus, one of Saturn's smaller moons, has become one of the most exciting discoveries in recent decades. Beneath its icy surface lies a hidden ocean, and that ocean doesn't stay contained. Cracks near the South Pole shoot giant plumes of water vapour into space, hundreds of kilometres high. Spacecraft like Cassini have flown through those plumes and found traces of salt, organic molecules, and tiny icy grains, signs of a potentially habitable environment beneath the ice. Imagine it. A small, frozen moon, glittering in Saturn's shadow, quietly releasing the breath of an ocean into the void. Enceladus shows that even the smallest worlds can hold immense secrets. Fact 45. Our moon slowly drifts away. Each year. It's easy to think the moon will always be right where it is, steady and eternal. But in truth, the moon is slowly drifting away from Earth, about 4 centimeters each year. Scientists know this because they've bounced lasers off mirrors left on its surface during past missions, measuring the tiny change over time. As the moon moves away, Earth's rotation gradually slows, making our days ever so slightly longer. Millions of years from now, the moon will appear smaller in the sky. And solar eclipses won't look the same. It's a gentle reminder that even the things we think of as constant, the tides, the sky, the glow of the full moon, are always changing slowly but surely in the quiet rhythm of cosmic time. Fact 46. The far side of the moon is not always dark. The phrase, dark side of the moon, has captured imaginations for generations. But in truth, there is no side of the moon that lives in permanent darkness. The moon is tidally locked to Earth, meaning it spins on its axis at the same pace that it orbits our planet. This perfect synchronization allows one hemisphere, the near side, to always face us, while the opposite side forever looks away. That unseen region is what we call the far side, not because it's dark, but because it's hidden from view. Both sides experience day and night as the moon travels around Earth. When sunlight washes over the far side, we can't see it from here, so it appears as though that part is eternally shadowed. In reality, it receives as much sunlight as the side we know so well. Lunar orbiters have captured its rugged terrain, pitted with ancient craters, mountain ranges and scars from cosmic collisions that go back billions of years. Unlike the near side, the far side lacks the wide, dark plains called Maria that give the moon its familiar face. When the Soviet spacecraft Luna 3 sent back the first images of this hidden hemisphere in the year 1959, humanity saw something entirely new. Later missions like NASA's Lunar Reconnaissance Orbiter revealed its full geography in breathtaking detail. The far side even hosts a few landing sites for robotic missions, quiet explorers studying what sunlight touches but we can never see directly. So the next time you gaze at the moon, remember this. The far side isn't dark at all. It simply keeps its secrets turned away, glowing quietly in the same sunlight that falls on your face. It's a reminder that mystery often hides not in the absence of light, but in the limits of our view. Fact 47. Moons can have their own mini-moons. Moons. It sounds almost like a joke, a moon that has its own moon. But in the strange, elegant mechanics of the cosmos, this idea isn't impossible. Astronomers call them submoons or playfully moons. While we haven't confirmed one yet, the physics behind it makes perfect sense. If a moon is large enough and its parent planet's gravity isn't too strong, there could be a tiny pocket of space where a smaller object might orbit around it. Imagine it, a little moon circling a larger moon, both revolving around a planet, all moving together around a star. It's like a celestial dance inside another dance. Layers of rhythm unfolding through space. Scientists have run computer models showing that under the right conditions, such systems could exist for millions of years before gravity pulls them apart. Take Saturn's Titan, for example. It's so massive that if any moon could have a submoon, Titan might be the one. Or perhaps Earth's moon long ago had a companion before the two eventually merged, leaving behind the scars we still see on its surface. There's also the possibility that when moons collide or break apart, fragments briefly orbit each other before drifting away into space. In the grand scale of the universe, we've only just begun to understand how complex orbits can be. Planets have moons. Moons might have submoons. Even asteroids can have smaller rocks tagging along. Everything circles something. bound together by invisible threads of gravity, like dancers who never quite let go. So while no one has yet spotted a true moon, the idea stays alive because it feels so fitting. In a universe that builds patterns upon patterns, why wouldn't moons also have companions of their own? Somewhere, far from our telescopes, there could be a small world orbiting another small world, moving together in silent harmony through the night. Fact 48. Pluto has a heart-shaped glacier. When the New Horizons spacecraft flew past Pluto in the year 2015, the world held its breath. Until that moment, Pluto had been little more than a blurry dot, a mystery frozen at the edge of the solar system. But as the images came in, one detail stole everyone's heart, quite literally, a bright heart-shaped region stretching across its icy surface. This heart isn't a trick of light. It's a real geological feature called Tombor Regio, named after Clyde Tombaugh, who discovered Pluto in 1930. The left side of the heart is a vast plain of nitrogen ice known as Sputnik Planitia. It's smoother and younger than the rest of the planet's surface, which suggests that something beneath, maybe slow, slushy convection, keeps renewing it over time. The ice here behaves almost like a liquid glacier. It creeps and flows, reshaping the land with a patience only the cosmos can afford. Craters are rare because the surface constantly erases its scars. Deep below, some scientists believe there might even be an underground ocean, locked beneath layers of rock and ice. New Horizons showed us that Pluto is far from a dead world. It has mountains of water ice that rise like frozen skyscrapers, and a thin, hazy atmosphere that changes as it orbits the Sun. The heart-shaped glacier has become more than just a geological feature. It's a symbol of discovery, reminding us that even tiny distant worlds can surprise us with warmth, shape, and beauty. When you look at that pale heart, frozen in the black of space, you can almost feel the quiet pulse of a world we nearly forgot. Cold, small, and distant, but still alive with wonder. Fact 49. Dwarf planets lurk in the Kuiper Belt beyond. Neptune lies a vast, icy wilderness, a ring of debris known as the Kuiper Belt. It's like a frozen fossil field, filled with remnants from the dawn of the solar system. And among that endless collection of icy rocks drift the dwarf planets. Pluto, Haumea, Makemake, Eris, and many others waiting to be found. These worlds are smaller than regular planets, but they follow their own elegant paths around the Sun. Some are round, others oddly stretched. Many are covered in ice so cold that nitrogen and methane freeze solid. Light from the Sun takes hours to reach them, and temperatures fall to hundreds of degrees below zero. The Kuiper Belt is more than just a distant edge. It's a time capsule. The objects here never grew into full planets because they were too far from the Sun, where the solar winds and gravity were weaker. Studying them helps astronomers piece together how the early solar system formed and why certain worlds like Earth turned out so different. Eris, one of the largest, is nearly as big as Pluto and even brighter. Haumea spins so quickly that it's shaped more like an egg than a sphere. Makemake glows with a reddish hue, dusted with methane ice. And beyond them all, there may still be hundreds of unknown dwarf planets, too small and too distant for our telescopes to yet see. Each one circles in quiet isolation, a frozen wanderer in the darkness. Small worlds keeping the ancient secrets of creation. Fact 50. The Oort cloud is the solar system's edge. If you could travel far enough from the Sun, past all the planets past the Kuiper Belt, you would eventually reach a place where our solar system fades into interstellar space. That vast, invisible boundary is the Oort cloud, a spherical shell of icy bodies surrounding everything we know. No spacecraft has ever reached it, and no telescope can see it directly. But we know it's there from the way long-period comets behave. Some comets take thousands or even millions of years to complete a single orbit, swinging in from the farthest reaches of this cloud before diving toward the Sun. When they do, their icy surfaces heat up and form glowing tails that remind us how far they've travelled. Scientists believe the Oort cloud might contain trillions of icy objects, leftovers from the early solar system, that were flung outward by the gravity of the giant planets. They form a kind of cosmic bubble, extending almost halfway to the nearest stars. Beyond it, the Sun's influence finally gives way to the pull of other stars in the galaxy. The Oort cloud marks both an ending and a beginning, the final whisper of our solar system before the deep interstellar night begins. It's a border that no human or probe has crossed, yet it defines the edge of our home. Somewhere in that silent frontier, comets sleep in frozen darkness, waiting for the rare moment when gravity calls them back, letting them blaze briefly across our skies before disappearing again into the cold. It's humbling to realize how far that boundary lies, and how even at the edge of everything, our solar system still holds unseen wonders. Fact 51. Light is both a wave and a particle. Light is one of the universe's most mysterious travellers. It behaves like a wave, rippling, bending and spreading through space. Yet, it also behaves like a particle, tiny packets of energy that strike matter one photon at a time. This dual nature of light puzzled even the greatest minds for centuries. Is it a wave? Is it a particle? The answer, wonderfully, is both. When light passes through two narrow slits, it creates a pattern of bright and dark bands, proof that it moves like a wave, with peaks and troughs that interfere with each other. But when we detect it particle by particle, it lands in discrete points, as if each photon made its own choice. It's as though the universe refuses to fit neatly into one explanation. Albert Einstein showed that light's energy travels in these little packets, photons, which can knock electrons loose and power everything from solar panels to photosynthesis. But when light travels through empty space, it ripples like waves on a cosmic sea. We live surrounded by this paradox, though it rarely crosses our minds. Every glow, reflection, and sunrise is the result of that delicate dance between the wave and the particle. Light isn't just what lets us see the universe, it's how the universe speaks to us. Every star, every galaxy, every faint glow carries its story across space in beams that are both continuous and discrete, smooth and sharp, wave and particle. Two sides of the same cosmic truth. Fact 52. Nothing travels faster than light. In the grand cosmic race, light always wins. No object, no signal, no force we know can move faster than it. In a vacuum, light travels at nearly 300,000 kilometers per second, fast enough to circle the Earth 7 times in a single heartbeat. This speed isn't just quick. It's a fundamental limit woven into the fabric of reality. When Einstein introduced his theory of relativity, he didn't just describe motion, he set the universe's speed limit. The faster something moves, the more energy it takes to keep accelerating it. To reach the speed of a light would require infinite energy, which nature simply doesn't allow. This limit defines how we experience space and time. Light is the ruler by which distance and time are measured. When we look at distant galaxies, we see them not as they are now, but as they were when their light first began its journey, millions or even billions of years ago. The stars we see tonight might no longer exist, but their light is still on its way, carrying their memory across the cosmos. So when you stare at the night sky, you're not just looking at space, you're looking at time itself, stretched out in beams of light that move faster than anything else ever could. Fact 53. Gravity can bend light. Gravitational lensing. In the vast reaches of space, light doesn't always travel in straight lines. When it passes near something incredibly massive, like a galaxy or black hole, gravity bends its path, curving it around the object. This phenomenon, called gravitational lensing, turns gravity into a cosmic magnifying glass. Einstein first predicted it in his general theory of relativity, and astronomers later saw it in action. Distant galaxies appear stretched, duplicated, or ring-shaped when their light is bent around something in between. The effect isn't just beautiful, it's incredibly useful. By studying the way light bends, scientists can map invisible things like dark matter, since only gravity strong enough to warp light could produce such distortions. Sometimes, lensing even lets us see galaxies too faint or too far for our telescopes to detect otherwise. Gravity focuses their ancient light, bringing the unreachable into view. It's as if the universe lends us its own telescope, allowing us a glimpse deeper into time. So when light bends, it's not breaking, it's revealing. Space itself curves, and light follows that curve faithfully. What looks like a trick of optics is really the shape of reality itself. Fact 54. A year is defined by Earth's journey around the Sun. We often take the passing of a year for granted, birthdays, seasons, calendars flipping from December to January. But what a year truly measures is a grand cosmic journey, one full orbit of Earth around the Sun. It takes about 365 days for our planet to complete that elegant circle, travelling at nearly 30 kilometres every second. As Earth moves along this orbit, its tilted axis creates the rhythm of the seasons. When one hemisphere leans toward the Sun, it basks in warmth and long days, while the other experiences winter's rest. The balance slowly shifts as we glide along our path, painting the world in cycles of growth and renewal. Ancient civilizations watched this movement carefully, marking the solstices and equinoxes, building calendars from the dance of light and shadow. Even today, our entire concept of time, agriculture, and tradition depends on this steady motion through space. Every year isn't just another chapter of life, it's another loop through the cosmos. Right now, as you read this, the Earth is moving around the Sun, the stars shifting ever so slightly overhead. A year, then, is more than time passing. It's our shared voyage through the vastness, a reminder that even standing still, we're always in motion. Fact 55. Time moves slower near massive objects. Time doesn't tick at the same pace everywhere. It bends and stretches, flowing differently depending on where you are. Near something massive, like a planet, a star, or especially a black hole, time slows down. This isn't science fiction. It's one of the strangest truths of relativity. Gravity isn't just a pull, it's a curve in space and time. The stronger the gravity, the deeper that curve, and the slower time moves for anything inside it. An astronaut standing near a massive planet would experience minutes, while someone far away might experience hours. We've even tested this on Earth. Atomic clocks placed on mountaintops tick slightly faster than those at sea level, because they're farther from the planet's centre of gravity. The difference is tiny, billionths of a second, but measurable. In the universe, near the edge of a black hole, the effect becomes extreme. Time practically stands still as gravity grips it tightly. This means the universe itself experiences time unevenly. In one corner, ages pass in moments. In another, moments last forever. It's a humbling thought. That time, something we think of as constant, is actually alive and flexible, shaped by the weight of the cosmos itself. Fact 56. Space and time are woven together. We used to think of space and time as two separate things. Space was where everything happened, and time was the ticking rhythm that carried it forward. But in the early 20th century, that idea changed forever. Einstein showed that they're not separate at all. They're one connected fabric called space-time. Picture this fabric as a vast, invisible sheet stretching across the cosmos. Every planet, star, and galaxy rests upon it, and their weight causes the sheet to curve. When a smaller object passes nearby, it follows that curve, what we call gravity. It's not that the planet is pulling, it's that space-time itself is bending, and motion follows the bend naturally. But there's more. Because space and time are one, when something moves through space, its flow through time changes too. The faster you move, the slower time passes for you. Near massive objects where space-time dips deeply, time itself stretches. It's a delicate cosmic balance. Motion, matter, and time, all tied together by invisible threads. Even though we can't see this fabric, we live inside it every second. Every sunrise, every heartbeat, every orbit. All of it unfolds within this woven web of space and time. It's not just the backdrop of existence, it is existence shaping everything that was, is, and will be. Fact 57. The universe has no true centre. If you could float out into the deepest part of space and look in every direction, you might wonder, where's the centre of it all? Where did the Big Bang happen? The answer is both simple and mind-bending. There is no centre. The universe doesn't expand from one point into empty space. It expands within itself everywhere at once. Imagine a loaf of raisin bread rising in the oven. As the dough expands, the raisins all move away from one another. No raisin sits at the center. Every point experiences the same growth. That's how the universe works. Every galaxy sees other galaxies moving away, not because we're all flying through space, but because space itself is stretching. There's no edge, no outer wall, no central origin you could point to. The Big Bang happened everywhere, and its echo lives in every direction. So when you look at the night sky, you're not staring toward the center. You're standing inside the unfolding of everything. The universe doesn't need a middle. It simply is, infinite and equal, stretching beyond any single point you could ever call home. Fact 58. Cosmic rays constantly pass through us. Right now, as you read these words, invisible travelers from space are passing through your body. They're called cosmic rays, high-energy particles born from violent events like exploding stars and colliding galaxies. Most are protons, racing across the universe at nearly the speed of light, striking planets, atoms, and even us without a sound. Every second, millions of these particles zip through the atmosphere, colliding with molecules and creating showers of secondary particles that fall like invisible rain. They pass through walls, oceans, mountains, and even our own cells, mostly harmless, sometimes changing a few atoms as they go. Scientists study cosmic rays not only to understand their origin, but also to trace the universe's most energetic mysteries. Some come from our sun during solar storms, others were born in places unimaginably far away, long before Earth existed. When one of these ancient particles hits a detector on Earth, it's like receiving a postcard from the edge of the cosmos. So while we move through our quiet daily lives, the universe is gently brushing past us, reminding us that even the smallest particles can carry the stories of stars. Fact 59. Energy can't be destroyed, only transformed. One of the most comforting laws in physics is the law of conservation of energy. Nothing truly disappears. Energy can't be created or destroyed, it only changes form. It's passed along, reshaped and recycled endlessly throughout the universe. When a star burns, it converts hydrogen into helium, releasing energy as light and heat. That same light travels through space, warming planets and powering life. Plants capture it, animals eat the plants, and we move through our days fueled by the same starlight that left the sun minutes ago. Even when something burns out or fades, the energy doesn't vanish. It just becomes something else. On a cosmic scale, every explosion, every motion, every heartbeat echoes this rule. Matter itself is a form of energy, as Einstein showed with his equation E=mc2. The atoms in your body were once part of stars, transformed and reformed countless times. It's a gentle truth. Nothing is truly lost. The energy that keeps you alive today has existed since the universe began, just changing costumes again and again, in an endless dance of transformation. Fact 60. Even empty space has quantum fluctuations. When we imagine empty space, we tend to think of pure nothingness, a quiet void stretching forever. But in the quantum world, even nothing isn't truly empty. Space seethes with tiny bursts of energy, appearing and disappearing faster than we can measure. These are quantum fluctuations, momentary ripples in the vacuum itself. For a brief instant, particles and antiparticles flicker into existence, then vanish as if they never were. This constant activity gives the vacuum a kind of restless hum, the lowest possible energy state nature allows. It's like the universe breathing at a level too small for us to hear. These fluctuations aren't just theory. They subtly influence the behavior of real particles and may even shape the structure of the cosmos. Some scientists believe that the entire universe might have begun as one such quantum fluctuation, a ripple that grew instead of fading away. So even in the vast quiet between galaxies, there's no such thing as true emptiness. Space itself is alive with potential, a restless sea of tiny possibilities flickering in and out of being, the whispering heartbeat of creation. Fact 61. Thousands of exoplanets have been discovered. For centuries, People looked up at the night sky and wondered if other worlds might circle those distant stars. For most of history, it was only a dream, until now. In the past few decades, astronomers have confirmed something extraordinary. Planets are everywhere, thousands upon thousands of them. The first confirmed exoplanet was discovered in the year 1995, orbiting a star called 51 Pegasi. Since then, telescopes like Kepler and TESS have turned that single discovery into an entire catalogue. Today we've found more than 5,000 exoplanets, each with its own orbit, climate and mystery. Some are gas giants larger than Jupiter. Others are small rocky worlds that could resemble Earth. We've found planets that race around their stars in just a few days, and others that take centuries to complete an orbit. Some are so close to their suns that their surfaces glow with heat. Others drift in the cold edges of darkness. And yet, each of them tells us that our solar system isn't special. It's part of something far greater. Every star you see could have planets around it. Billions of stars, billions of worlds. The universe isn't just filled with light, it's filled with places that could just possibly hold life. Fact 62. Some planets orbit two suns. If you've ever imagined standing on a world with two suns in the sky, you're not dreaming. Such planets really exist. These are circumbinary planets, worlds that orbit not one but two stars locked in a slow, elegant dance around each other. From the surface of such a planet, day and night would look extraordinary. Sometimes both suns would rise together, casting twin shadows across the land. Other times, one might set while the other still shines, bathing the world in a softer double sunset. Astronomers have already discovered several of these systems, including Kepler 16b, often nicknamed the Tatooine planet. It's a gas giant, not a place we could walk on, but its existence proves that planetary systems can form and remain stable, even in the complex gravity of two stars. Life around twin suns would face strange rhythms, shifting seasons, complex patterns of light and heat. But in the grand puzzle of the cosmos, it's just another reminder that nature's creativity knows no bounds. Two suns, one world, a harmony of motion playing out across the light years. Fact 63. Hot Jupiters defy expectations. When astronomers began discovering planets around other stars, one type immediately puzzled them. Hot Jupiters. These worlds are massive like Jupiter, but they orbit incredibly close to their stars. Some are so near that a year lasts only a few Earth days. Their skies blaze with heat. Their clouds may be made of metal, and their winds scream at thousands of kilometers per hour. What surprised scientists most was their location. Gas giants shouldn't form close to a star. It's too hot for the gases to condense. Yet here they are, defying the rules. The best explanation is that these planets formed farther out, then slowly migrated inward, drawn by the gravitational currents of their star's early disk. Hot Jupiters glow from the inside, their atmospheres puffed up and shimmering like lanterns. Some even appear to be evaporating, their gases trailing behind them like tails. They're proof that the universe doesn't follow our expectations. It writes its own story, full of surprises that challenge what we think we know about how worlds are born. Fact 64. Super-Earths may be common. Imagine a planet a little bigger than Earth, massive enough to hold a thick atmosphere, but small enough to remain rocky and stable. Astronomers call these worlds super-Earths. They don't exist in our solar system, but out in the galaxy, they seem to be among the most common kinds of planets. Super-Earths can be up to 10 times the mass of our planet. Some might have oceans that stretch for thousands of kilometers, others could be dry, mountainous, or cloaked in thick clouds. Depending on their distance from their stars, they could be cold and icy or warm enough for liquid water. We've found super-Earths orbiting small red dwarfs, bright suns, and everything in between. Because they're so diverse, scientists believe some of them could be habitable, not Earth-like, but life-friendly in their own strange ways. They remind us that Earth isn't the only model for a living world. Somewhere among those billions of stars there may be countless, almost Earths, each with its own skies, seas, and possibilities waiting quietly in the dark. Fact 65. Rogue planets drift alone in space. Not every planet has a star to call home. Some worlds wander the galaxy alone, untethered, drifting through the deep cold between stars. These are rogue planets. Scientists think they were once part of solar systems, born beside their stars until a gravitational encounter, maybe a passing planet or a stellar companion, flung them into the void. Once cast adrift, they travel endlessly through darkness, carrying the memory of the warmth they once knew. A rogue planet doesn't orbit light. It carries its own faint heat, slowly fading over time. Some might have thick atmospheres that trap warmth, or even underground oceans warmed by internal energy. Though they seem desolate, they could still hold secrets, perhaps even conditions where life might cling to survival in the dark. There may be billions of these worlds in our galaxy, silent travelers between the stars. Invisible, cold, and free, they drift like lost notes in the endless song of the universe. Proof that even in isolation, a world can still exist with quiet dignity. Fact 66. Some planets rain diamonds. In the universe, weather can take some truly exotic forms. On some distant worlds, it doesn't rain water or snow. It rains diamonds. These aren't tiny sparkling flakes falling softly through the air, but massive chunks of crystallized carbon, forged under pressures far beyond anything on Earth. Scientists suspect that on planets like Uranus and Neptune, the combination of extreme heat and crushing pressure turns carbon into diamonds. Lightning storms may even help form them, driving chemical reactions in the dense atmospheres. Then, gravity pulls these diamonds downward, creating showers of glittering stone deep inside the planet. Imagine standing on a world where the sky is full of turbulent winds and storms, and deep below, diamonds cascade silently through layers of clouds and gas. These rains are invisible to the eye, hidden inside thick atmospheres, but their existence shows how wildly different other worlds can be. Diamond rain is a reminder that the cosmos doesn't just create familiar Earth-like patterns. Nature experiments with chemistry and physics in ways that make our imagination seem tiny. It's another whisper from the universe, letting us glimpse the extremes of possibility. Glittering treasures falling silently where no human could ever stand to see them. Fact 67. Others are made, almost entirely of gas. Not all planets are solid. Some are immense spheres of gas, barely holding a recognizable shape. Jupiter and Saturn in our solar system are examples, but exoplanets reveal that gas giants come in incredible varieties, some hotter, some larger, some glowing faintly in infrared light. These worlds have no hard surface, only swirling clouds and storm systems that can rage for centuries. Winds scream around them at thousands of kilometers per hour, creating colorful bands and vortices that shift and change in mesmerizing patterns. Some gas giants are so massive that their gravity squeezes their gases into strange, dense states, forming interiors that behave more like fluids than solid rock. Despite their size and chaos, gas giants can host moons, rings, and complex magnetic fields. They shape the architecture of their planetary systems, shepherding other worlds and debris into orbit. In a way, these gaseous titans are the silent conductors of their solar neighborhoods, massive and dynamic yet impossible to touch. Gas planets show us that worlds don't need solid ground to be fascinating. They are giant laboratories of physics, where matter, pressure, and energy combine to create phenomena that defy everyday understanding. Fact 68. Exoplanet atmospheres reveal hidden clues. For a planet's surface may be hidden, but its atmosphere can tell its secrets. By observing starlight passing through the gases above a planet, scientists can detect its chemical fingerprints. This technique, called transit spectroscopy, reveals what the planet is made of, whether it's full of hydrogen, methane, carbon dioxide, or even water vapor. Atmospheric studies have uncovered hazy worlds, scorching storms, and signs of exotic chemistry that challenge expectations. For example, some hot Jupiters glow with strange colors, hinting at metal clouds or unusual molecules. Others show escaping hydrogen, revealing that their atmospheres are slowly being stripped away by the heat of their stars. By studying atmospheres, astronomers can also assess whether a planet might support life as we know it. Even subtle clues, like oxygen, carbon compounds, or temperature gradients, provide glimpses into worlds light years away. Every detection is a tiny window, a way of reading a planet's story without ever leaving Earth. Exoplanet atmospheres remind us that even the invisible can speak, carrying secrets from the most distant corners of space into our telescopes and minds. Fact 69. The habitable zone is a cosmic sweet spot life. As we understand it, needs a delicate balance. Too close to a star and a planet overheats. Too far and it freezes. The region where conditions are just right for liquid water is called the habitable zone, a cosmic sweet spot that stretches around stars like a warm ribbon. Earth lies in this zone, where sunlight is mild enough to allow oceans, clouds, and rivers to form. Beyond it, Mars is cold and dry, while Venus is a runaway furnace. For other stars, the habitable zone shifts depending on their size and brightness. Red dwarfs have narrow close-in zones. Massive blue stars cast wide zones that may exist only briefly in cosmic time. Planets in these zones aren't guaranteed to host life, but they are the most promising places to look. Water can pool, weather can cycle, and chemistry can flourish. Even if life never emerged there, these planets are laboratories for understanding what conditions are necessary for it. The habitable zone reminds us how rare and fragile balance can be, not just on one planet, but across the cosmos. It's the narrow line where the universe allows water to flow, storms to form, and maybe, just maybe, life to take hold. Fact 70. The nearest exoplanet is Proxima. Just over 4 light-years away, orbiting the star Proxima Centauri, lies our nearest known exoplanet, Proxima b. It's slightly larger than Earth, and orbits close enough to its star to potentially have liquid water, at least in theory. Proxima Centauri is a red dwarf, smaller and cooler than our Sun, so its habitable zone is very close. Proxima b would experience long periods of dim sunlight, punctuated by stellar flares that might bathe it in radiation. Its day-night cycle could be strange, perhaps with one side always facing the star. Even though it's just our cosmic next-door neighbour, we can't visit it yet. The distances are vast, and current spacecraft would take tens of thousands of years to reach it. But Proxima b represents hope, a nearby laboratory for studying rocky worlds, habitability, and the variety of planets beyond our own system. Looking toward Proxima b is like peering into our future. It's close enough to imagine, distant enough to feel the awe of the cosmic scale, and real enough to remind us that the universe is full of neighbours waiting quietly in the dark. Fact 71. Quasars shine brighter than galaxies. Some objects in the universe shine so brightly that they outshine entire galaxies. These are quasars, powered by supermassive black holes at the centres of distant galaxies. When gas, dust, and other matter spiral into these black holes, they heat up to extraordinary temperatures and release incredible energy, producing a light that can travel billions of light-years to reach Earth. From our vantage point, quasars appear as tiny, almost star-like points of light, but in reality they are engines of unimaginable scale. A single quasar can emit more energy in a year than hundreds of billions of stars combined. Their light can illuminate the early universe, allowing astronomers to peer back in time to when galaxies were forming. Quasars also act as cosmic lighthouses. Their brightness reveals the presence of gas and matter between us and them, tracing the invisible structures of the universe. Some quasars flicker, their light waxing and waning, reminding us that even the brightest objects are dynamic, changing with time. The thought that a single object can shine so intensely, yet remain just a pinpoint in the sky, is humbling. It reminds us how vast and powerful the universe can be, and how small our place within it truly is. Fact 72. Magnetars have the strongest magnetic fields. Magnetars are among the strangest and most extreme stars in the universe. They are a type of neutron star, the dense remnants of massive stars that have collapsed under their own gravity. But what makes magnetars truly remarkable is their magnetic field, the strongest known in the cosmos. A magnetar's field can be 1,000 trillion times stronger than Earth's. To imagine it, think about a refrigerator magnet so intense that it could wipe all electronics on Earth from thousands of kilometers away. These fields twist and snap the star's crust, causing bursts of X-rays and gamma rays that briefly outshine the sun by millions of times. Magnetars are rare and short-lived compared to normal stars, but their presence reminds us how extreme the universe can get. They are celestial powerhouses, laboratories of physics that stretch the limits of what matter and energy can endure. Even from thousands of light years away, their energy reaches us, whispering the story of forces far beyond ordinary comprehension. Fact 73. Gamma ray. Bursts are the most powerful explosions. Among the universe's most violent events are gamma ray bursts. They occur when massive stars collapse into black holes or when neutron stars collide. For a brief moment, a gamma ray burst releases more energy than our sun will emit over its entire lifetime. These bursts can shine across billions of light years, carrying intense beams of radiation through space. If one were to happen close to Earth, it could affect our atmosphere, though thankfully they are extremely rare nearby. Gamma ray bursts are cosmic fireworks on a scale almost impossible to imagine. Brilliant, sudden, and powerful. Astronomers study these bursts not only to understand the death of massive stars, but also to glimpse the early universe. The light from gamma ray bursts carries information about galaxies and matter billions of years away, acting as flashlights into the distant past. They are reminders that the cosmos is alive with both creation and destruction, unfolding on scales far beyond human experience. Fact 74. Cosmic dust seeds new worlds. Even the emptiest parts of space are not truly empty. Tiny grains of cosmic dust drift silently through the galaxy, carrying the raw materials for planets, stars, and even life itself. These dust particles may be no bigger than a micron, yet their collective presence shapes entire solar systems. When clouds of gas and dust collapse under gravity, the particles collide and stick together, forming planetesimals, the building blocks of planets. Over millions of years, these tiny grains grow into rocks, then worlds. Without cosmic dust, stars would form, shine, and die, but planets would never take shape. Cosmic dust is also responsible for the beautiful colours we see in nebulae. Light scatters off these particles, creating glowing clouds in shades of red, blue, and gold. Every planet, including Earth, began as a humble collection of dust floating through the void. So when you look at the night sky, remember, the dust between the stars is not empty. It is the universe's seed bank, quietly crafting new worlds, patiently waiting for gravity to weave it into life and structure. Fact 75. Nebulae are star nurseries. Nebulae are some of the most enchanting objects in the universe. These vast clouds of gas and dust are stellar nurseries where new stars are born. Within their colourful and swirling expanses, gravity pulls material together, forming clumps that grow hotter and denser over time. Eventually, these clumps ignite nuclear fusion, and a new star lights up the darkness. Nebulae come in many forms. The glowing, vibrant emission nebulae lit by young stars, the dark nebulae that block light and hide secrets within, and the planetary nebula formed from dying stars shedding their outer layers. Each one is a stage in the life cycle of stars. These nurseries remind us that the universe is constantly renewing itself. Even as some stars die, new ones are taking their place, born from the very remnants of previous generations. In a way, every twinkle in the sky has a story that began in a nebula, a quiet cloud of gas, dust, and endless possibility. The next time you look at the Milky Way, imagine the hidden nurseries within, vast, colourful, and alive with creation, cradling stars before they even emerge into the cosmic night. Fact 76. The pillars of creation still glow in the Eagle Nebula. Far out in space, in a region called the Eagle Nebula, lie the famous pillars of creation. These enormous columns of gas and dust stretch light years into the cosmos, glowing softly as they cradle newborn stars within their shadows. The pillars are made of dense clouds of hydrogen gas, dust, and plasma, slowly eroding under the intense radiation of nearby stars. Within these towering structures, pockets of gas collapse under gravity, giving birth to new stars that will someday shine across the universe. In some ways, the pillars are both a graveyard and a nursery. Old gas and dust are consumed, while new light begins its journey. Even though they are thousands of light years away, we see them as if frozen in time. Their delicate glow, captured by telescopes, reminds us of the slow, patient processes that shape galaxies and stars. They are a testament to the beauty and persistence of creation, on a scale almost impossible to imagine. Standing under their imagined shadow, one can almost feel the weight of cosmic time, vast, unhurried, and endlessly creative. The pillars of creation remind us that even in the dark reaches of space, light and life are quietly taking shape. Fact 77. Gravitational waves. Ripple through space-time. Space isn't perfectly still. When massive objects like black holes or neutron stars accelerate or collide, they send ripples through the fabric of space-time itself. These ripples are called gravitational waves, and they carry information about some of the universe's most energetic events. Gravitational waves travel at the speed of light, stretching and compressing space as they pass by. They are subtle. A wave might change distances by less than the width of a proton, yet they carry enormous energy and reveal cataclysmic events billions of light years away. We first detected these waves in the year 2015, when two black holes merged. Their collision sent a pulse through space-time that reached Earth, whispering across the cosmos about a moment that had happened over 1 billion years ago. Gravitational waves are like cosmic messengers. They let us hear events that would otherwise remain invisible, opening a new sense with which to explore the universe. They are proof that space itself is alive, capable of rippling and responding to the dance of massive objects across time and distance. Fact 78. Cosmic strings might be leftovers from the early universe. Some theories suggest the early universe left behind unusual structures called cosmic strings. These are not strings in the usual sense, but incredibly thin, dense filaments of energy stretching across space. If they exist, they are leftovers from the first moments after the Big Bang. Cosmic strings would carry immense tension, warping space-time around them and potentially creating gravitational effects that could be detected across billions of light years. They could leave faint patterns in the cosmic microwave background, hinting at the universe's infancy. While we haven't confirmed their existence, the possibility of cosmic strings reminds us that the universe may hold remnants of its earliest moments hidden in plain sight. Tiny threads of energy, older than galaxies, may still ripple silently through space, a quiet echo of creation itself. Fact 79. Some black holes emit powerful jets. Black holes are famous for swallowing everything nearby, but some also push material out. Certain black holes, especially supermassive ones at the centers of galaxies, emit colossal jets of energy and particles. These jets can stretch thousands of light years, blasting through surrounding gas and dust. The exact mechanics are complex. As matter spirals into the black hole, magnetic fields twist and funnel some material along the poles at nearly the speed of light. These jets can shape galaxies, trigger new star formation, or clear out gas in their paths. Though black holes are often imagined as dark and silent, these jets are a cosmic roar, visible across millions of light years. They remind us that even objects defined by gravity and absorption can have influence, shaping the universe in powerful ways. Fact 80. The universe may be teeming with invisible phenomena. For all we can see, most of the universe remains hidden. Dark matter, dark energy, black holes, and other invisible phenomena govern the motions of galaxies and the expansion of space. They are unseen, yet their influence is everywhere. Dark matter holds galaxies together, preventing them from flying apart. Dark energy drives the accelerating expansion of the universe, shaping its ultimate fate. There may be forces, particles or objects we haven't even imagined, quietly threading through space. The invisible universe reminds us that what we see is only a fraction of reality. Much like an iceberg, most of existence lies hidden beneath the surface. By studying the shadows, the motions, and the subtle effects on light and matter, scientists are slowly unveiling a cosmos far richer and stranger than our eyes alone can perceive. It's humbling to realize that the universe is more than meets the eye, an ocean of mystery, stretching endlessly, full of wonders we've only begun to sense. Fact 81. The universe could expand forever. One of the most profound questions about the cosmos is how it will end. Observations suggest that the universe is expanding, and it might continue to do so forever. Galaxies are moving away from each other, and space itself stretches continuously, carrying them farther apart. If expansion never slows, Stars will eventually burn out, galaxies will drift beyond each other's view, and the universe will grow colder and emptier. Light from distant galaxies will fade, leaving vast stretches of darkness punctuated only by the last lingering stars. This is sometimes called the heat-death scenario, a slow, quiet fading of cosmic energy over unimaginable timescales. The idea can feel almost melancholic. The universe, once bright with countless stars, gradually becomes a silent, lonely expanse. Yet it's also beautiful. Expansion is part of the natural rhythm of the cosmos, a reminder that change is constant, and even emptiness has its own kind of order. While this may happen trillions of years from now, it connects us to the grand story of the universe. Every moment of light, warmth, and motion today exists against the backdrop of this slow, eternal expansion. Fact 82, or it might collapse in a big crunch. Not all theories predict endless expansion. Some suggest a future where gravity eventually overcomes the stretching of space, pulling everything back together in a colossal reversal called the Big Crunch. In this scenario, galaxies would slow their outward motion, then start moving toward each other. Stars, planets, and eventually all matter would converge. Space itself would shrink, compressing everything into an unimaginably dense state, perhaps resembling the conditions at the very beginning of the universe. A big crunch is a dramatic vision, unlike the slow fading of eternal expansion. It imagines a universe collapsing in on itself, an immense cosmic heartbeat that eventually returns all things to a singular point. While modern observations suggest expansion is accelerating, the possibility reminds us that the fate of the universe is still a profound mystery, governed by forces and energies far beyond our everyday experience. Even if it never happens, imagining a big crunch gives perspective. Our lives, our galaxies, even the stars we see in the night sky are part of a dynamic, ever-changing cosmos, where beginnings and endings intertwine. Fact 83. The Big Rip could tear everything apart. Another fascinating, if unsettling, possibility is the Big Rip. Unlike the slow heat death or the collapse of a big crunch, the Big Rip imagines an accelerating expansion that grows so extreme it could eventually tear everything apart. Galaxies, stars, planets, even atoms themselves. This scenario depends on the mysterious force called dark energy, which is driving the acceleration of the universe's expansion. If dark energy grows stronger over time, its repulsive effect could overcome gravity and all other forces. Galaxies would drift apart faster than light, planets would detach from stars, and matter itself might be ripped apart. Though purely theoretical for now, the Big Rip illustrates the raw power of cosmic forces. It reminds us that the universe is not a fixed stage, but a place of dramatic tension, where the rules of space, time, and matter can play out in ways almost unimaginable. Fact 84. Stars will eventually burn out. Every star has a life cycle. They are born from clouds of gas and dust, shine for millions or billions of years, and eventually exhaust their fuel. Even the Sun, a middle-aged star, will one day burn out, leaving behind a dim remnant called a white dwarf. Massive stars end their lives with spectacular supernovas, scattering their elements across space to seed new stars and planets. Smaller stars fade quietly, their light dwindling over eons. Eventually the universe will be left with dim stars, stellar remnants, and black holes. A cosmos far quieter than the one we see today. This natural fading is not frightening. It is a reminder of the delicate balance of energy and time. Stars are transient, beautiful phenomena, giving light and warmth for finite spans before passing their energy back into the universe. Fact 85. Black holes will slowly evaporate. Even black holes, though seemingly eternal cosmic monsters, are not truly permanent. Thanks to a phenomenon known as Hawking radiation, black holes can slowly lose mass, emitting tiny particles over vast stretches of time. For small black holes, evaporation could occur over billions or trillions of years. For supermassive black holes, the process is unimaginably slow, taking longer than the current age of the universe. Eventually, even these giants may vanish, leaving only energy behind. This gentle disappearance is a quiet reminder that nothing in the cosmos is eternal. Time and energy persist, but forms change. Even the darkest, most extreme objects in space are subject to the universe's ongoing transformation, a slow, patient rhythm that continues long after we're gone. Fact 86. In the far future, the universe will go dark. Imagine a universe trillions of years from now. The stars we know will have burned out, leaving behind dim remnants like white dwarfs, neutron stars, and black holes. Galaxies will drift apart so far that even the nearest stars may vanish from view, leaving the cosmos in near-complete darkness. This is a vision of the far future, a quiet, silent universe, where light has faded and only the faintest echoes of past brilliance remain. Planets, if they still exist, would orbit cold, dead stars or float through interstellar space, lonely and unlit. Even time itself would seem to stretch differently as the cosmos cools and expands. It's a humbling thought. The universe, once filled with fire and motion, gradually giving way to stillness. And yet this darkness is not chaotic. It is orderly, predictable, the natural conclusion of the processes that began with the Big Bang. Even in this quiet, the universe holds the memory of every star that ever shone and every galaxy that ever spun. Fact 87. This final era is called the heat death. Scientists call this ultimate fate the heat death of the universe. It doesn't mean the universe will burn, rather it will reach a state of maximum entropy, where energy is evenly distributed and no work can be done. Stars will no longer form, black holes will dominate, and matter will be sparse and cold. During heat death, the universe will approach a uniform temperature close to absolute zero. Movement will slow, collisions will become rare, and light will be scarce. Even black holes, slowly evaporating through Hawking radiation, will eventually disappear. It is a serene, almost poetic end. A universe that fades into stillness, neither chaotic nor violent, simply quiet. Every particle, every photon, every atom that once danced in fiery brilliance will have played its part, leaving behind a cosmos at rest. Fact 88. Yet new universes might be born again. Even after heat death, the story might not end completely. Some theories suggest that new universes could emerge from the ashes of the old, each with its own stars, galaxies, and possibilities. Perhaps in regions of extreme energy, a fresh Big Bang could ignite, creating a universe with different laws, colours, and rhythms. It's a comforting thought. Even in the emptiest darkness, creation might begin anew. The cosmos is resilient, cycling through birth, growth, decay, and rebirth on scales far beyond human comprehension. Each ending may carry the seeds of another beginning. Fact 89. Multiverse theories suggest infinite realities. Some scientists propose that our universe is only one of countless others, a multiverse, where infinite realities exist simultaneously. Each universe could have slightly different physics, stars, planets, and possibilities. Some may mirror our own, others might be unrecognizably strange. In one corner of the multiverse, gravity might be weaker or stronger. In another, time might flow differently. These possibilities stretch our imagination, suggesting that the cosmos is far richer and more mysterious than the light we see. Multiverse theories hint that even as one universe fades, countless others might flourish, quietly existing beyond our perception. The darkness of heat death in our universe could be just one small thread in an infinite cosmic tapestry. Fact 90. Somewhere, another you might exist. If the multiverse exists, it opens a tantalizing, almost poetic possibility. Somewhere, another version of you might exist. Perhaps one lives on a planet with two suns, another in a world of diamond rains, or one drifting silently on a rogue planet. These alternate realities might follow paths wildly different from your own, shaped by different choices, circumstances, or cosmic events. It's a reminder that the universe, or perhaps the multiverse, is unimaginably vast, creative, and full of possibilities. Even if we can't reach these other realities, thinking about them expands our perspective. Our life, our universe, and every moment of existence are part of a grander, almost infinite story, one that stretches far beyond the stars we see and the worlds we know. Fact 91. We are made of stardust. When you look at yourself in the mirror, it's humbling to realize that the atoms composing your body once belonged to distant stars. Every element heavier than hydrogen and helium, carbon, oxygen, nitrogen, iron, was forged in the cores of stars long before our sun even existed. Massive stars lived and died, exploding as supernovas that scattered these elements across the galaxy. Over billions of years, these stellar remnants collected in clouds of gas and dust, eventually forming new stars, planets, and life. In a very real sense, we carry the history of the universe within us. Thinking about it this way makes every heartbeat and breath feel like part of a much larger story. The matter that forms your body has travelled across time and space, participating in a cosmic journey that stretches back to the very beginning of the universe. We are not separate from the cosmos, we are part of it, composed of the same building blocks that light up the night sky. Every glance upward reminds us that the stars above and the matter inside us share a common origin. Fact 92. Every atom in you was once in a star. Every atom in your body has a history. The iron in your blood, the calcium in your bones, even the oxygen you breathe was created inside a star that lived and died long before Earth existed. These atoms were cast into space by supernovas or gentle stellar winds, eventually becoming part of the molecular clouds that birthed our solar system. When you hold this in your mind, you realize that you are made not only of matter, but of history. Each atom has travelled across the galaxy, through the chaos and beauty of the cosmos, to become a tiny piece of life on Earth. In that sense, being alive is more than biology. It's a connection to the universe itself. You are a bridge between distant stars and the world around you, carrying cosmic history in every cell. Fact 93. The universe is nearly 14 billion years old. The universe is ancient, nearly 14 billion years old. That vast stretch of time allows for galaxies to form, stars to live and die, and planets like Earth to emerge. To think in human terms, it's almost impossible. It dwarfs all human history and even the lifespans of entire civilizations. Every star we see has its own age, its own journey. Some are younger than our sun, just beginning to shine. Others have already died, their remnants scattered across space. Every moment we live occurs against this immense, unbroken flow of cosmic time. Considering the age of the universe reminds us that we are observers of a story far older and grander than ourselves, witnessing just a brief chapter in the long life of the cosmos. Fact 94. Human eyes can see only a tiny slice of the spectrum. Our eyes are remarkable, yet limited. They can perceive only a tiny fraction of the electromagnetic spectrum, the narrow band we call visible light. Beyond it lies an immense world of radiation. Radio waves, infrared, ultraviolet, X-rays and gamma rays, all carrying information about stars, galaxies and energetic events far beyond what we can see naturally. Telescopes expand our vision, allowing us to see the universe in these other wavelengths. Infrared light can pierce through dust clouds to reveal newborn stars, while X-rays expose the violent deaths of massive stars. Every new wavelength we explore opens a fresh window into the cosmos, showing us that what we perceive with our eyes is only a small part of reality. The universe is far more intricate than our senses alone can grasp, and yet every glimpse we gain adds to our understanding of the vast, complex cosmos we inhabit. Fact 95. The night sky shows light from long ago. When you look up at the night sky, you're not seeing stars as they are right now. You're seeing the light that left them years, centuries, or even millennia ago. Some of the stars might have already burned out, yet their photons continue to travel across space, carrying their story to our eyes. This delayed light turns the night sky into a time machine. Each twinkle is a glimpse into the past, a frozen moment from a distant place. The Andromeda Galaxy, for instance, appears as it was 2.5 million years ago, long before humans walked the Earth. The universe is not static. It is a flowing, dynamic stage, and the night sky shows its history in subtle, beautiful ways. Every star and galaxy we see is a reminder of the cosmic journey of light and time, stretching across the unimaginable distances of space. Fact 96. Our galaxy alone has billions of Earth-like worlds. The Milky Way is vast, stretching over 100,000 light-years across, and within it may lie billions of planets similar to Earth. Some orbit stars like our Sun, in regions where temperatures could allow liquid water. Others might be just slightly larger or smaller, with climates, skies, and landscapes unlike anything we can imagine. Even though we haven't visited them, these worlds exist as quiet possibilities, scattered among the countless stars overhead. The idea that our galaxy alone could host so many Earth-like planets is humbling. It reminds us that life, in some form, may not be unique to our tiny blue planet. As we gaze at the Milky Way, each sparkling point of light could be home to a planet teeming with rivers, oceans, or perhaps entirely different forms of life. Every star is a sun, every sun a potential centre for a new world, and somewhere, unseen, countless Earth-like possibilities quietly orbit in the cosmic night. Fact 97. The universe may be conscious in its own way. Some theories suggest that the universe is more than a collection of stars, galaxies, and matter. Perhaps it possesses a form of awareness, not in the way humans think, but a subtle, emergent property of its immense complexity. Patterns emerge across cosmic scales, from the spin of galaxies to the cycles of stars hinting at an underlying order. Even if this consciousness is abstract, it encourages a different perspective. We are part of a universe that is alive with processes, rhythms, and feedback. Our own awareness, our curiosity about the cosmos, may be a reflection of this vast network of connections. Whether or not the universe has awareness in any literal sense, contemplating it invites wonder. It reminds us that life, thought, and matter are woven together, and that the cosmos is not merely a backdrop but a participant in its own unfolding story. Fact 98. We're all moving through space together. Every moment our planet, our solar system, and even our galaxy are moving through space. Earth orbits the Sun at almost 30 kilometers per second. The Sun orbits the center of the Milky Way at more than 200 kilometers per second, and the galaxy itself drifts toward other galaxies in the local group. Despite these incredible speeds, we rarely feel this motion. Gravity keeps us anchored, and the vast emptiness of space means collisions are rare. Yet it's comforting to realize that we are all traveling together through the cosmos, riding on our planet through the grand celestial dance. Every person, every tree, every ocean, and every building moves in harmony with this invisible flow, part of a cosmic rhythm stretching across light years. We are simultaneously grounded and in motion, connected to the universe in ways both tangible and profound. Fact 99. Every second, the universe grows larger. The universe is expanding, and every second it grows a little larger. Space itself stretches, carrying galaxies farther from one another. Stars that once seemed near may drift beyond sight over billions of years. This expansion is subtle yet relentless, shaping the cosmos in ways we can barely perceive. This growth means the universe is not static. Every moment distances increase, and the cosmic landscape subtly changes. Light travels longer, and the observable universe gradually shifts, revealing new galaxies and phenomena. Even though we live in just a tiny corner, we're witnessing a universe in motion, endlessly stretching into the unknown. The expanding cosmos invites patience and awe. Time and space themselves are not fixed, but flowing, dynamic, and alive with change. Fact 100. You are part of the cosmos, and the cosmos is part of you. After all these facts, perhaps the most profound truth is this: you are not separate from the universe. The atoms in your body were forged in stars, your energy flows along the same cosmic laws, and your existence is part of the universe's ongoing story. In turn, the universe shapes you. Its cycles, forces, and structures guide life on Earth. Every thought, every breath, and every heartbeat is connected to the grand tapestry of space and time. Falling asleep while contemplating this connection can be calming. You are part of something vast, beautiful, and enduring. The stars, galaxies, and cosmic rhythms continue around you, and yet you are intrinsically woven into the very fabric of existence. The universe is not distant. It flows through you, carries you, and surrounds you. Tonight, as you drift into sleep, imagine that you're both small and infinite, a single thread in the endless story of everything.